given f prime, we want to figure out when f is increasing and decreasing as we move around the unit circle from 0 to 2 pi. So to answer this question, it's important to know where the derivative is equal to 0, because where it's equal to 0 is a place where it could potentially switch from positive to negative. So if we know where it switches, that's going to help us determine our intervals. So first we say that theta is 7 pi over 6 and 11 pi over 6. Those are our places where f prime could potentially switch signs. So 7 pi over 6, 11 pi over 6. Okay, that's where derivative's equal to 0. Now, for this one, it's actually easier to see how this thing starts as we move around our unit circle, because sine is positive in these top two quadrants. So sine, which is a component of the derivative, is positive in the top two quadrants. And then we're adding another positive number to that sine value. So a positive plus a positive has to be a positive in these top two quadrants. All right, then think about what happens as we cross over pi down here, right? Sine is now negative, but it's still really close to 0, right? It's a negative number and we're adding 1/2 to it. Once it hits negative 1/2, which it will at 7 pi over 6, we'll have negative 1/2 plus 1/2, which will be equal to 0. But before that, it's still positive. The other thing is it can't switch negative until it crosses through 0. So if we go around this circle and we say it starts positive, the only place it could possibly switch negative is once it hits the place where it's equal to 0. So it hits 7 pi over 6 where it's equal to 0, and now if we were to pick an angle bigger than 7 pi over 6, look, that y value is negative, and it's definitely a larger value than 1/2. So we're going to do a negative number whose value is bigger than 1/2 plus 1/2 is going to result in a negative. So as we suspect, at that place where it switches, where it hits 0, it switches from positive to negative, and then it's going to stay negative until it hits 0 again, where it's going to switch back positive. So we say this thing is increasing from 0 to 7 pi over 6, and also 11 pi over 6 back to 2 pi, and then it's decreasing from 7 pi over 6 to 11 pi over 6. And that's all we need to know. We don't care about what the original function is. We're given the derivative. We can determine where this thing is increasing and decreasing. Okay. So same thing for f prime theta equals 8 cosine theta minus 4. We're going to set it equal to 0 and determine when the derivative is equal to 0. So this is going to be when cosine theta equals 4 over 8, which is 1/2. Okay, that is at pi over 3 and 5 pi over 3. Let's draw our circle. There's pi over 3. There's 5 pi over 3. All right. Now, if you think about this function, 8 cosine theta minus 4, we know that cosine starts with an output of 1 at an angle of 0, which means at an angle of 0, we have 8 times 1, which is 8, minus 4, which is positive 4. And as we move away from that angle of 0, this value is still going to be larger than negative 4, which is going to produce a positive output. And then once we hit the place where the derivative is 0, it's now going to switch negative. And then once it's negative, it's going to stay negative until it hits 0 again, because to go from negative to positive, you have to cross back through 0. When we do that, we cross back through 0, we switch back positive. So we are increasing from 0 to pi over 3, and also from 5 pi over 3 to 2 pi, and then we are decreasing from pi over 3 all the way until 5 pi over 3. All right. Last one, we have 2 sine theta minus root 3 is our derivative. We'll set it equal to 0 again. 2 sine theta equals root 3. Sine theta equals root 3 over 2, which happens at pi over 3 and 2 pi over 3. So when we draw our circle, pi over 3, 2 pi over 3. That's where we're going to potentially switch from positive to negative or negative to positive. How does this thing start, though? Well, at an angle of 0, sine is equal to 0. So this whole piece goes away, and we just subtract root 3, which would be negative. And as our angle gets bigger, this piece is still going to be smaller than this piece because of sine starting out so small, as a 0 approaching a larger value. So we start out negative, for sure. And then once we hit that place where the derivative is 0, now our sine value is approaching, right? Our y value is getting bigger now, right? And we've just crossed through that 0. So now we've switched positive, and we will stay positive until we cross through 0 again at 2 pi over 3, and now we go negative again. All right, so now we are decreasing from 0 to pi over 3, and also from 2 pi over 3 all the way back to 2 pi, and then we are increasing from pi over 3 to 2 pi over 3. And that's it. Done.